Welcome to the gmStudio FileExplorer sample demo. In this video, we're going to take you end-to-end through a small upgrade. We're going to rewrite a VB6 application to functional C# code. That's going to include some of the analysis, the Kami API replacements, dealing with language compatibility challenges, and a little bit of testing. Along the way, we'll look at how gmStudio works behind the scenes and some of the configuration files used to do deeper migration. Let's get started by looking at the VB6 program. It's got a single form that has several ActiveX controls on the screen. A tree view, a list view, rich text box, some image lists, a status bar, and a toolbar. There's also a menu and a checklist box. When you run the program, it uses the scripting runtime to find all the drives on the machine and scan their folders. You can then drill down into the folders and see the folder contents. You can open the files and look at the content of the files. And you can also check and uncheck the tree view items. I also have list view sorting and a few other features like selecting a file and printing out its info. You can also resize this and resize this using this. There's a picture box here that they use as a slider to emulate a splitter frame. So let's say we want to get an initial standard translation of this little VB6 program. We're going to use the wizard to help us set that up. We showed the wizard in our previous video. So first we're going to select our program and confirm that's the program we want to translate. Just click Next. We're going to create a FileExplorer demo. We're going to go ahead and generate resx files because for those image lists we need that. And we're going to go ahead and try to build. Again, we're going to C#. We're going to begin with a stub framework. Those are pretty much the standard settings for a standard upgrade. This part's completely automatic. You can see it's generating the COM information, generating the resource files, creating the translations, deploying the translations, building the upgrade, and also ran a bunch of assessment reports that we'll look at a little later. Clicking Next, we could send this over to Great Migrations for some feedback. We can review the results, and we're just going to finish and continue into gmStudio. So here we are. After the wizard is complete, we've got our gmStudio project. We've got our workspace that has our project file in it. It's got our rules files that were generated for us. It's got the interface description files describing all of the COM APIs. It's got the .NET translation. Also review some of the reports. And in addition, we can open the .NET code from here, rebuild that. That all builds. If we want to look at the form, we see something strange. The form doesn't look right because this standard translation uses a stub framework for all of the COM dependencies. So here's our tree view, here's our list view, and so forth. But the tree view is actually just a stubbed out WinForms control. In fact, all of these controls are just stubbed out at this point. So the form has placeholders for the COM components, but the intrinsic controls are rendered. And you can see in the document outline that all the content of the form is present. So as we move forward, we want to take this standard translation to a custom translation where all of the COM components and COM APIs are replaced with .NET, and the form renders properly and the application runs. So how do we get to a runnable code? Our methodology has really two phases. First is a standard upgrade. That is producing translations that build. Again, that involves gathering up the VB6 code and the COM dependencies, creating a standard upgrade solution that does the translation and the build, and then resolving any issues that come. So here we are at this stage now. We're going to now begin going through the steps of the custom upgrade. A custom upgrade can best be thought of as implementing a set of custom upgrade features. And that's going to include various structural improvements, COM API replacements, dealing with language incompatibility problems. Also, if you want to get rid of Win32 API calls and replace those with .NET services, as well as value-added features, implementing generic collections, various architecture and coding standards, or DevOps conventions, whatever it is, there's really no limit to what you might want to do as part of your upgrade. And gmStudio is designed to have the flexibility to allow you to do those things. So we're going to be walking through the process of implementing custom upgrade features. That's also referred to as translation tuning. And we're going to see some techniques like taking snapshots of the upgrade solution, rules and results, and comparing the impact of adding various rules. We're going to understand the concept of translation scripts, build models, and translation rules that are used for mapping COM APIs to .NET, directing the migration of VB6 language features to .NET, and others. So we're on the gmStudio main form, and this is where you'll spend most of your time when you're developing upgrade solutions. The wizard that we've been looking at is primarily to help people that are new to gmStudio with setting up a project. We're going to be, this is a very simple project with only one VBP. So in the task list, we'll just keep this task at the top here selected. We're going to be running batch operations for the most part. Translate, deploy, build, and compare. And we will normally turn off this dialog when you start the batch. You could also have it display every time you start the batch. Again, that's helpful for people that are new to the tool, but generally you're going to want to translate, deploy, and run a quick build test on each iteration. And you can also compare a snapshot. We'll talk about snapshots more in a second. We will display the session log every time we start a batch, and we'll show up to 1,000 lines. So I'm going to go ahead and start it. And we can see we are going to run the translation, deploy the translation, build, and compare. So we can see we're running the translation. That completed. And then we're deploying the translation. And then we are going to do a test build. And we have conventions for integrating with different versions of Visual Studio, and all the details of how you want to do your builds can be configured. The entire process took about 4 seconds and produced a translation that builds. We can review some of the artifacts produced by this process. We've got our translation log. We can also view that as a grid that shows what was loaded and processed. We've got our deployment log. We can also view that as a grid that shows, except that's actually a display of the content of the translation bundle. And we'll talk about bundles in a second. And you can also look at the build log. The build log won't have any grid because there's no errors or warnings to report. Here's our task details. The next thing we want to do is add a second job to this translation solution for the purposes of facilitating the demo. I want to have 2 jobs so I can go back and forth and show the impact of adding rules one by one. So let's go through that process real quickly. To add a job, you could add it using this add task form. But what I'll typically do is actually edit the backing data. That opens the translation data in Excel. I'm going to copy that. I'm going to paste that in here. And we're going to call this managed. The key thing here is going to be this translation script, which I'll change in a second. So by changing this task tag, I've created a whole separate profile of this translation. So the source we're going to be translating is the same, but the task has a different tag. So it can have different rules and different attributes that allow us to do side-by-side work on two different configurations. So save that, go back over to gmStudio and load it. Since I'm running in trial mode, I get that warning, and I'm going to validate the source again. So now you can see we have our two tasks in here, and these things are more or less identical, but I can run this translation here. I can actually run both translations by hitting Alt-T. I can run both. You can see they're identical right now because they use the same translation script. We're going to be changing this second translation script in a moment. So I said the two translations we have here are identical because they have the same number of lines of .NET code produced in the translation. But they're not exactly identical. In fact, I'm going to snapshot both of them now. So we have them snapshotted. But you can also compare two jobs. One of the most important things to set up in gmStudio is going to be the comparison tool you're going to be using. You can set that up right here. What's your comparison viewer and your comparison command line. Using comparisons to see the impact of various rule changes or source code changes or tool changes is a critical part of the incremental upgrade methodology. So I can select these two jobs and see them side by side. What we're looking at now is two snapshots. So these are SNP files. SNP files can be configured. The content can be configured. What we can see is that right now, both of the jobs are using the same translation script. The snapshot has three parts. You've got the translation script, followed by the actual translation log, followed by the translation results. And you can see the results, the 2,749 lines of generated code is the same on both sides because the source is the same, the script rules are the same, and we're using the same version of the tool. The only thing that differs in these translations is the actual name of the log, the name of the output bundle, and so forth. So that's the impact of having a different task tag on these two tasks, or what I was calling jobs. Sometimes I call them tasks, sometimes I call them jobs. But basically, they are configurations of rules and source code that are run through the translator. So as I've been talking about gmStudio, I've been talking a lot about translation scripts. So what is this translation script idea? A translation script is typically going to be an XML document. We actually call this gmPL, GM programming language. It's an XML-like notation that's processed by our translation engine. And it looks a lot like XML, but it's a little bit more forgiving than XML. It's not case sensitive, and it allows a few syntax issues. It lets them slide. In any event, this script is what is actually what's called a template translation script. You can see it's got commands with attributes or XML elements, also known as commands, with some attributes that direct the details of those commands. For example, this first element here is a storage element. It tells the translator to create a file to store the translation model. That's a very detailed binary model that's read by our proprietary information management system. Then there's a set of commands that are going to set up the locations of various configuration files that will contain rules and COM descriptions and those types of things, inputs and outputs to the process. Then there's the standard set of translation options that we put in the default script, and followed by the processing commands. We're going to tell the tool to compile the code, does a couple passes over the code, analyze the code, and then we're going to open a file to receive the translated output, author the output, and then close that file, and then finally close the storage area. So right now, both of these translations use the same script. And it's the same script template, FileExplorer demo, standard tran.xml. So now I want to change this second upgrade project task to use a different translation script. One way to do that is to edit this attribute here. So I changed the translation script template name there. And now if we look at this one, we'll see it has a very different set of a different script template with some different rules. There's a variety of things, and we're going to go through what some of these differences are and how they impact the translations as we move forward. So first thing I want to do is once again take a snapshot of this. Now I'm going to run the translation. And we can see the translation has changed quite a bit. The standard one is 2,749 lines, and the custom one is 1,538 lines. If I compare these two, we can see that the translation script has changed. For example, we have the standard, and this, what we're looking at here is what we call the actual translation script, not the script template. The actual translation script has been detokenized. All of the variable placeholders have been populated by gmStudio with information from the upgrade configuration. And we can see, for example, we changed this build file. We had optional arguments on, which is actually a default in the tool now. We've got a different project GUID. We've got this block of refactoring commands has come in here. These registry commands have come in on the custom. So you see there's basically a number of custom rules that are being passed to gmStudio, or they're being processed by the translator when it processes the code. We can also now looking, the next piece of the snapshot is comparing the logs. So we can see that some additional processing occurred in author text. We can see some additional, the COM upgrade rules are being loaded and so forth. And then getting into the actual translation, we can see we've added a couple assembly references, and we've removed that whole stub framework that I was talking about. Remember, the standard translations, their purpose is to help us validate that the upgrade is well formed, and we use the C# compiler to check that for us. So we're not trying to do any actual transformations or COM upgrades that really, different teams are going to have different standards for how they want to do COM upgrades. So we don't hardwire that into the standard translation. Standard translations use a stub framework. These custom translations do not. And you get, see, like the rich text box is replaced. There's just a whole lot of changes that have taken place just by changing the rules. Just by changing text-based, XML-based rules outside of the core tool, we've produced a completely different translation. And there's a lot of detail to this. Obviously, this particular translation has a number of upgrades, which we're going to go through them in a little bit more detail. There's obviously way too much detail to run through in the context of a quick demo, and I'm trying to keep the demo under 30 minutes if I can. We'll have separate videos that do deeper dives on these topics for teams that want to do more ambitious software reengineering at a large scale. But you can see the translations have come out very different, and you can see it when you compare these. The other big difference down here is the standard translation has this whole set of stub framework files, this big block of content that's only on the left. That's that whole stub framework that the tool generated by analyzing how you used COM APIs and VB6 language elements that translate into framework support stub code. And just going back to this, if I want to basically translate this, deploy it, and build, it does all build. If we go over to Visual Studio, now we're going to look at our form, and guess what? It looks fine. Now we have a real WinForms tree view, not a stub tree view. We have a real list view and a real rich text box, or a WinForms text box, WinForms status bar, WinForms toolbar. We are going to run this code, and we can drill down, and again, doing things like sorting, doing things like seeing inside files, getting the info about a file, and so forth. And again, the resizing works. If you're looking very closely, you'll notice the time and date on the status bar do not actually work. That's because the default WinForms status bar does not directly support panels of type time and date that are synced with the operating system in real time. So this particular implementation, we just put the word time and date in there. If you really wanted to see the time and date, of course, you can look on your taskbar now. If you really want to see time and date, you would need to implement runtime support, a custom panel that's going to run a timer and update those things in the background. That's just something that Microsoft decided they weren't going to support out of the box in WinForms. And there's a lot we can say about, what Microsoft decided to drop support for as they moved to WinForms. But that's one example of something that we lost. So you can see that this particular translation does not use any interop assemblies. It does have an external library that provides some support. That library, I should probably redo this translation just to embed this as code. It's a helper library that provides support for list view sorting. That's another thing that the Microsoft left out of their WinForms implementation, was the ability to easily sort list views. Well, I shouldn't say easily. They implemented an object-oriented sorting pattern where you attach a sorting helper class to your list view so that it can deal with things like numeric sorting, date sorting, categorical sorting, basically something more sophisticated than alphanumeric sorting all the time. But out of the box, you don't get any sorting now. So if you want some sorting at all, you need to implement a list view helper and a list view sorter class that provides that support. And we integrate that with the translation. And we'll walk through quickly the rules that were used to do those things as we move forward. So let's start with COM replacement as a custom upgrade feature. That's arguably one of the most important features that you will have in your upgrade project, because there are so many different great .NET libraries out there that provide better support for debugging and integration with .NET. Also, COM interop is an unsavory proposition at best. I could go into more detail on that, but just let's leave it at it's difficult to debug. There are performance issues, security issues. It's 32-bit. just a lot of details around dealing with COM interop that you're going to want to avoid. So being able to migrate pretty much any COM API to a .NET replacement is probably our number one feature that we want to support. And the way we typically do it nowadays is through what's called refactor libraries. So we are registering refactor libraries that are going to be automatically applied when the translator encounters a VB6 code or an ASP site that references one of these, one of the indicated COM APIs. So let's look at this, a simple case. Rich text 32, that's the rich text box library. We're telling the tool, if you see a code that references rich text 32, load this refactor file. So let's look at that refactor file. I've moved that in here into the user folder. And this is again, a refactor file is also an XML document. You can also do this with gmAPI or gmSL script, but the typical way to do it is with gmPL migrate commands. So this XML document loads and overrides the default set of rules. The default internal rules in the translator are going to produce a code that uses a stub framework or uses Interop. This library is going to be automatically loaded and applied on top of the rich text XML document. So you can't understand refactor libraries unless you understand these interface description files. The interface description file is an XML document that describes in detail the elements of a COM API. So in this case, the rich text box API has a rich text box like an inbound interface, an outbound event interface, and there is a rich text box that exposes both of these interfaces, the logic, what we call the logic interface, and the event interface. There's a few other classes in this library that have to do with ActiveX and more abstract ways of programming rich text boxes. You'll also see the enumerations and some other things that have to do with different versions, type defs for different versions. There's a lot of information that you can find inside an interface description file. Again, these files are generated by gmStudio from the COM binary, and they're a key input. The refactor library is a set of rules that are attached to the API elements in the associated COM API. So in this case, rich text box is also known as rich text 32.ocx. That's its type lib ID. And we can see this refactor command is applying to that type lib ID so that all of these identifiers of things that we're migrating are going to be resolved within the rich text box API. So you can see we're renaming things, and we're dealing with how events are handled, and we're mapping enumerations to their replacements in .NET. Basically, any API element can have a number of migration attributes attached to it, so that will direct how it's being rewritten. In this case, we're also saying that the library itself is migrating to WinForms, which is an internal library that's going to reflect that we don't need to do anything special to reference that, because WinForms is going to be loaded by default for our projects. So we also say we don't need to declare anything. So that handles the library. Then we handle the API elements. And then very important down here is a MIG class in the net control namespace. It's the net control rich text box. And that namespace is used to direct the authoring of designer code. So we can see that we're going to author back color, an enabled property, and font, location, scroll bars, and so forth. If we wanted to add additional properties, we could add additional mappings here. So I've done a couple translations now, and I'm going to compare them. On the left is a translation I ran with the refactor library for rich text box commented out. And on the right, I have the rich text box refactor library activated. Looking at the log, you can see where we loaded. The tool sees the reference in the VBP, and then it says, oh, okay, you've got a refactor library registered for this. So we're going to load your refactor library. You can see on this is the custom translation without the refactor library. It targets Interop. And then you can see, for example, this was the Interop namespace of rich text of the rich text box versus the system Windows forms. So that's one of our differences. Then you've got instantiation, and you've got this. All this over here is what you need on the .NET side for Interop. We rarely do this. I'm only doing it for the sake of the demo. What we really want to look at here is what did we get once we activated the rules. We can see our designer code is here. Also can see that the key press handler changed to use a key event args, and we have introduced this preamble to give us the legacy arguments that we might need, specifically the key code associated with the rich text box. And then we've got a rename here, and we can see this OCX state is something we add. That's something you need if you're using Interop. That's been removed. So it's a fairly small set of changes needed for rich text box. This code doesn't really do a lot with the rich text box except for initialize it in the designer. You can see the font made it through. The second migration we're going to look at here is the scripting runtime upgrade. And it is handled by another refactor library shown here. This particular migration also includes not only the declarative migration rules that allow you to do all manner of simple transformations on atomic operations of the API, but it also includes a migration event handler that will do deep migrations, the more difficult migrations. The deep migrations are handled, for the sake of this demo, by gmSL routines. gmSL is our scripting language, and it is a C-like API that integrates deeply with the translation engine, allow you to implement dynamic translations. We don't have time to go into depth on this, but let's just say that these gmSL routines are going to be automatically invoked by the translation engine, and they are going to use specialized metadata for custom translation operations and custom translation types that bridge the gap between the scripting runtime object model and the .NET API object model, specifically system.io. For whatever reason, Microsoft's default IO library looks a lot like Java. It doesn't look like scripting runtime. So some of the operations just look very different in terms of how you open a text file and so forth. A key point about this is that this particular file is actually distributed with the product. In fact, there's a bunch of sample translation rules here. So if we look for scrun, you can see that's the library we're looking at and the transform. Those are distributed with the tool, and they can be activated by adding these rules to your script and bringing the appropriate script rule files into your workspace. Let's turn this one off, and I'm going to basically snapshot this, run another translation, and we're going to compare. And now you'll see, so I've commented that out. You see basically we're no longer loading the refactor library or the deep transformation rules. Now we're migrating now to, without those rules, we're going to get an interop reference. Let me flip this. So if you don't have those rules, you're going to have an interop reference, and we're still going to have scripting.folder, but now we're going to have system.io.directory info. That's a simple rule. The migration knows that there's no file system object anymore. Almost all the file system object services are implemented through static functions in system.io or one of the classes in system.io. Here's one of our deep migrations. This for each drive used to return drive objects. Now it returns strings. So you need to actually reconstitute a drive object from the string. And that's kind of what some of that deep migration was doing. Then you've got, again, another simple translation. Is ready changes to exists. You've got another simple translation here. A root folder path becomes root.fullname and so forth. So you can see all these, the effect of that, the effect of activating those translation rule files, the refactor library and the associated gmSL script does a full migration of system.io, at least insofar as this code is concerned. If we go back real quickly and look at, the question was, well, how do you know what this code needs? If I'm going to do a quick, we're going to look for scripting in the references report, and we can see that the tool can tell us exactly where scripting is used in the legacy code. And we can even peek at some of the details around that code. Say we want to look at 10 lines surrounding each reference. So you've got the drive object is used here. And member name, member class, member type. There we go. So where the co-classes are used, where the enumeration entries are used, even when it's implicit. So this is an implicit reference to the IO mode in this open text file call. So you see, that's something that you can't tell just by looking at the code. You need to have a full description of the API behind the scenes to know that this particular method has some default arguments, optional arguments. If we want to go look at that, go look for open text file in the IDF, we can see that IO mode is in fact an optional argument. The default is for reading. Create is a Boolean. The optional is false. So even though in our code we see that all we're doing is just a default open text file, we know that it's for reading, and that's the implication. So this text stream is going to migrate to a reader. That's the type of deep migration that's going on when we're rewriting scripting to system.io. Last but not least on COM APIs is going to be this Microsoft Windows Common Controls. There's actually a couple different versions of this library. We're looking at the main one, or the most popular one, and we've got a refactor library for it as well. This also has a few deep migrations, and it contains all kinds of objects that may or may not be used in the code. We've got a tab strip, we've got toolbars, we've got status bars that have panels, a panels collection with panel objects. Progress bar is a very simple thing. Looking for example, progress bar, there's not a ton to it. You know, the default is going to migrate to value. The max is going to migrate to something called maximum. The min, something called minimum, and the value is, the name stays at value. It's just an integer. A lot of this in here to deal with migrating the progress bar events. Then you've got tree view is a much more complex translation. There's a lot more properties, methods, and events on tree views. And the tree view has a nodes collection and node objects. There's a bit of nastiness with tree views in terms of the traversal order. I'm not going to cover that in this video, but in VB6, traversal order was linear, and now it's hierarchical. So something to be aware of in migrating this API. Then list view and column header. And again, we've got some other special refactor library features here to deal with some designer code complexity. And then we have for each API or for each control, we'll have a designer MIG class that directs the tool on how to generate .NET designer code from the VB6 designer code. And also some classes to assist with migrating logic where the APIs are different. So we have designer MIG classes for status bar and panels and so forth. And there's, these are very detailed migrations. They're, difficult to do by hand, but they can be completely automated with gmStudio using the appropriate rules. And again, rules are just text files. They're XML documents. They can be generated with a text editor after you do the research, or you can just activate the ones we've already developed and extend those or customize those as needed for your project. One of the things we're going to be doing in 2026 is teaching AI how to help us develop these rule files so that we can expedite the process of extending and validating these rules and enhancing or extending the capabilities of the translator. So I've already got this set up where I've translated this both ways. And on the left, we had WinForms turned off, or the common controls migration to WinForms was commented out, and then we turned it on, and you can see we're now loading. One of the things you see differently in the translation log is that we're loading the image stream from the regex information cache. That's another deal. If you know about COM image lists, they stored images in kind of as bitmaps or icons behind the scenes, and we've changed those over to, I think they're all bitmaps on the .NET side, stored as serialized image stream. So that's handled by the translator. And then you can see quite a bit has changed in terms of the declarations of the controls, the initializations of all the controls, and also in the logic. So on the left side is the default translation, and on the right side is the upgraded translation. Okay, and you could see, this mscom.ctl node goes to a tree node. Selected item.index becomes selected node.index. Get node count is actually a runtime extension method that we're bringing in. I believe that decides whether you want to do a recursive descent of the child nodes or not, and so forth. And there's our image streams instead of these clunky OCX state. So as I mentioned, the WinForms version of the list view does not support sorting the same way as the COM list view did. And we, on our sample, we've implemented a list view sorter class, and we put it in a library called gmRTL.mscom.ctl.dll. And we need to add a reference to that assembly in order to use that helper class. In order to introduce that, there's a lot of different ways this could be done, but the way we've done it here is to take advantage of a basically it's sort of like an abstract method called add user references that is in the authortext.gmSL. Authortext.gmSL is a standard system gmSL script that directs authoring all kinds of information that is not directly correlating with content from the legacy code. So for example, your .NET project file, your assembly info file, some of the boilerplate around classes and forms and things like that. That content isn't described by the legacy code. It's described in author text. And one of the services of author text is to add references to external assemblies needed by the translation. So we're bringing in a reference to gmRTL.mscomctllib.dll, which I've developed separately from the demo. And what we want to do here is we're telling the tool that I want you to load this gmSL script into the author text class and basically override add user references.gmSL. So that will allow us to insert that. So for example, if we go back in here and we comment this out and we translate, snapshot, translate, compare, you can see a block changed, and we go in here and we see that reference is removed. And you can see up here at the top, we can see at the top that we have commented out this command, this gmSL command. So we are no longer overriding add user references. When we don't override it, we don't get that custom block added. So if you want to add assembly references, as you know, or NuGet package stuff or content like that, you can put it in there. Dealing with dependencies can be a bit of a complex business. It always has been, dealing with external references, but gmStudio provides an extensive set of features to allow you to deal with that complexity and make it manageable and repeatable in terms of how you handle it. The next set of rules I want to talk about is this refactoring block. The refactoring blocks can contain many different types of operations that allow you to rename things, change the types of things, remove code, add code, reauthor code, inserting handwritten code. There are commands for dealing with generics, nullables, late binding, you name it. There's a lot there. This is a very simple case here. We're using the fixed type to introduce a meta type, Twips-to-Pixels. So if in VB6, screen geometry, 95% of the time, maybe even 99% of the time, screen geometry was expressed in a unit called Twips, which is typically we treat it as a 15th of a pixel. It's a very small unit, whole number unit. When we go over to .NET, WinForms, screen geometry is always expressed in pixels. So if you have logic that is involved with screen geometry, placement of controls and sizing of controls and moving controls around, a lot of times those operations will involve numeric constants that are in the Twips coordinate system, and you need to re-express those in the pixel coordinate system. So a lot of that is handled automatically by the tool. We have this meta type called Twips that we can say, okay, many controls have a height, a top, height, left, and width. They have those properties, and they're declared as integers, but they're really in units of Twips. So Twips are, if we tell the translator that a variable or argument or constant is of type Twips, then the Twips-to-Pixels transformation will be applied to calculations involving that symbol. So for example, I've already done a couple translations again with this being done both ways. And if we compare, so on the left, I've got the Twips-to-Pixels commented out, and on the right, it's turned on. So you can see, for example, I told it split limit is in Twips. So the tool automatically is going to divide by 15 there. Here's another change here. Let's see what else I put up here. I also said that this parameter was originally declared by ref, but it can be treated as a by val. That's actually a marshalling optimization after looking at the code. Even though they were changing it, they weren't actually doing anything with it afterwards. So by changing it to by val, we can just pass that value. We can pass a property in. It doesn't have to try to pass it in by ref. The same thing down here. Here's another call to size controls. Same issue there. And then on this actual size controls method, we can see that it was declared to take a float, but now we've migrated it to Twips, which needs to be an integer. And you can see wherever X is used, we've made the Twips-to-Pixels transformations. And it makes the translation quite a bit cleaner and more correct. Without having this migration on, you're going to get a translation that does not look right. So let me deploy this, and we'll go look at this in Visual Studio. Oh, darn it. I need to actually, let me comment this out, save this. I'm going to translate, deploy, and build. Translate, deploy, and build. And then jump over here. It says, okay, let's reload that. And you can see it doesn't look right. And also the sizing doesn't work. And I can't move this. The logic doesn't handle it right. But if I tell the tool, if I tell the translator to go ahead and apply that, and I translate, deploy, and build again, reload again, now, and run it again, now it works as expected. So that's another example feature of the FileExplorer sample is Twips-to-Pixels. One of the last features of the custom upgrade that I want to talk about has to do with what we call the gmRuntime library. If we compare the standard and managed translations, you'll see that these translations were done with what's called build file equals local. And again, that directs the translator to implement a support framework, which is going to be a bunch of .NET stub classes, and embed those classes as stub files in the .NET project. So you can see that. So select build file local on this side and build file equals off on the other side. Build file equals off, it will by default try to do Interop translations unless we apply upgrade rules to migrate to a different .NET assembly. There's also a build file equals global that separates the stub framework from being embedded code files to being external stub projects. I'll discuss build file in more detail in its own deep dive video. But you can see on this side we've got a couple gmRTL libraries, one called gmRTL Core and one called gmRTL GUI. But on the .NET side, we're just referencing gmRTL core.dll, and that's handled through by setting that build file to off and setting the library location to /bin. We end up getting this reference. That file is typically going to be deployed in the bin folder under the deployment by default on the standard samples. We just make a copy of that binary. Anybody with a gmStudio license can get the source code of gmRTL. There's a sample runtime library that's available as is, no warranty with the translator. When we do projects with teams, we will use gmRTL and validate it and trim it down to what's needed by the client system. So on the left is with build file equals local, and on the right is with build file equals off. We end up with an assembly reference, and that library is used to make the translations cleaner. Using the runtime library is not a requirement. So to recap, we implemented a number of translation tuning options. We used snapshots to help us compare and validate the impact of adding different rules. We learned a little bit about translation scripts and the different build models. And we learned a little bit about custom translation rules to map COM APIs to .NET replacements, deal with language issues, and other features. This is, of course, just the tip of the iceberg. In future videos, we'll be looking at the ASP to ASP.NET capability of the tool and various deep dive topics, looking at more detail into COM, API, and control migrations, custom VB6 language migration, the reporting and searching capabilities, and how to use script rule files to implement dynamic gmPL, as well as looking at using gmStudio with AI and much more. Thank you for watching. Learn more at greatmigrations.com.